Namaskar. In this video, we will discuss the chi-square test of homogeneity. This test is basically used to check whether the observed frequencies are distributed evenly over a period of time, let's say for example over a period of number of days or weeks or hours or years for that matter, evenly or homogeneously or not. To understand the concept better, let us take up an example of number of people visiting a tourist spot in different months of a year were noted. From the given data, can this be concluded that the tourist spot is equally popular round the year? If the tourist spot is supposedly equally popular round the year, then the number of people visiting that particular place should be evenly distributed over the entire year. Now, to check this, first of all, we need to see the observed frequencies. It has been observed, let's say for example, the people visiting in the month of January in terms of thousands are 14. That means 14,000 people visited the tourist spot in the month of January, 12,000 in the month of February, and so on. Now, because this particular test is asking for the distribution of the tourists evenly over a year, hence it qualifies for the test of homogeneity. The procedure for the calculation of the test statistic, that is chi-square, will be the same as that in case of goodness of fit, which is summation of O minus E square over E. Now, to solve the question, first, step by step, we need to test the hypothesis. The first step in this case will be the statement of hypothesis, which will be there is no significant difference between the observed frequencies and the expected frequencies. In statement form, it can be said that the tourists are equally popular, the tourist spot is equally popular year round. The null hypothesis is supported by the alternate hypothesis, which will say that the observed frequencies and the expected frequencies are not equal, or there is a significant difference between the observed frequency and the expected frequency. In statement form, the tourist spot is not equally popular year round. The second step will be to decide upon the level of significance and the degree of freedom. As nothing is mentioned in the question, the level of significance by default will be taken up at 5%, which is equal to 0.05. The degree of freedom is based on the number of observations. As the number of observations are for 12 months, so n is equal to 12, and the formula for degree of freedom being n minus 1, the value of degree of freedom will be equal to 12 minus 1, which is equal to 11. The next step is to calculate the test statistic. For the test statistic, as we discussed earlier, we will be requiring two things. One is the observed frequency and the other is the expected frequency. As we know that the observed frequency is already mentioned in the question. Now what about the expected frequency? For the expected frequencies, we have to understand that if the tourist spot is equally popular, it is assumed to be equally popular. That means same number of people or equal number of people must visit that spot each month. Now, if we calculate a total of people visiting that tourist spot in an year, the total is equal to 120,000, which means each month it should be 120 divided by 12, which is equal to 10,000. So, the expected frequency for each month will be equal to the total frequency divided by the total number of cases, which is equal to 120 divided by 12. So, the expected frequency becomes 10. Now, for each month, we have got the data of observed frequencies as 14, 12, 7, 7, and so on, and the expected frequencies are taken up as 10 each. For the test statistic, as per the formula, first we need to calculate the difference between the observed frequency and the expected frequency. Let's say for the month of January, if the observed frequency is 14 and expected frequency is 10, so O minus E will be equal to 14 minus 10, which will be equal to 4. Then we need to calculate the square of the difference between the observed and the expected frequencies, which will be equal to 4 square, which is equal to 16. And then finally, we need to divide this square of the difference with the expected frequency. So 16 divided by 10 will be equal to 1.6. Similarly, we need to calculate the O minus E square divided by E for each row, which comes out to be 1.6, 0.4, 0.9, 0.9, 0, and so on. The last step will be to find a summation of the last column, which is equal to 8.60. Now that we have calculated our test statistic, that is chi-square calculated, which is equal to 8.60, we come to the concluding step in the research hypothesis testing, which is the comparison of the observed and the expected value of chi-square, or we can say the calculated chi-square value and the standard chi-square value. For the standard chi-square value, we need to refer to our chi-square table, where we need two things. One is the level of significance, which was taken as 0.05, and the other the degree of freedom, which was taken up as 11. For chi-square, for alpha equal to 0.05 and nu equal to 11, the chi-square standard value is equal to 19.675. Now we have both the values, chi-square calculated equal to 8.60 and chi-square standard equal to 19.675. As we discussed earlier, the chi-square test is a right-tailed test, which means the rejection region lies on the right-hand side. That is, if the chi-square calculated value is higher or more than the chi-square standard value, then only the null hypothesis will be rejected, else it has to be accepted. So now, because the chi-square calculated 8.60 in this case is smaller than the chi-square standard value, which is equal to 19.675, which this means that the chi-square calculated lies in the acceptance region, which means that the null hypothesis may be accepted, or we can say that the tourist spot may be equally popular year round. So with this, we finish with our chi-square test of homogeneity. Thank you.